This
Where are the
conference will now be recorded.
Ma'am, I have given you this
Very
presenter rights. Can you share your screen?
is my
Absolutely.
screen not visible?
Sure.
Just let me share because option is not given to me.
Okay.
Right now, I have not become the presenter, I think.
Sudipto,
Just give
Sudipto,
me a minute. Just yeah. I can do it.
This conference will now be recorded.
Ma'am, can you see the option?
Yes, now I can. Now I'm getting the option.
Okay.
Uh, Now my screen is visible to everyone and my voice as well.
Yeah, ma'am.
Okay. So a very good morning to honorable professors, faculties from academia, and people from industries, and all the other respective participants, including the students. First of all, I thank to the whole team of the Anurag University to collaborate with us to hold this faculty development program, and this is a very uh, good opportunity for me and my company as to deliver you the upskilling routing technology from Typhoon HIL, that is GmbH Switzerland, with a specific focus on hardware in loop simulation. So we are pleased to introduce our simulation software named Virtual Hill Device and real-time emulators and microgrid testbed for electrical domain in the field of power electronics, power system, renewable energy source, solar, PV, wind, HVDC, pack devices, and there are many more. So this is Khushbu Purwar, Assistant Technical Manager in Quads Info System, Kanpur Typhoon Hill, presenting before you all. Okay. So coming towards the here today, we will discuss about the contents regarding this, that what is who we are, and brief introduction regarding the testing development stages and Typhoon Hill technology and software installation. The main purpose for discussing all these things is that, like, for over the decades, you must be knowing that all the PCs have been more progressive nowadays, and they have switched on towards the many more advanced technologies like simulation and real-time simulation. And this is a very effective field in which our engineers as well as research scholars are working. So it is definite to be updated to the latest technology. So here we are presenting you before. Typhoon Hill Incorporation is the market and technology leader in the rapidly growing field in of ultra high fidelity controller hardware and loop simulation for power electronics, microgrids, and distribution networks. We provide the industry proven vertically integrated test solution along with the highest quality customer support. The company was founded in 2008 and since then has been creating products distinguished by ultimate ease of use and unrivaled performance, leading edge technology, and affordability, thus bringing the products to fruition and meeting time to time market goals as well. So these are the three important persons which we need to mention. Not these three important persons, I must say that there are a number of engineers behind the success and the leading Typhoon HIL to the top market position, but these are some of the important persons. Like this is the first person who comes to our mind, that is the Ray Starter, the president of the board. Then Dushan Magistravic, he is the chief technical officer and the most footing person of this technology and the most important person and founder member and CEO, that is Nicola Fisher, who was earlier instrumentation engineer at ABB Switzerland, and there he developed the processor technology called MATA, and Typhoon HIL is based on this technology. He is the most powerful footing of this Typhoon HIL, and so as the name and the logo, you can also see that this is a mammoth, and this is also a very powerful. And typhoon, it is the name of a cyclone and it is also a powerful cyclone. So the tool is named according to this scenario, and he is the most footing person of this and the most powerful tool. Hence its symbols as our working office in Uttar Pradesh, that is in Kanpur, and it is Quads Infosystem. It is the sole authorized distributor for Typhoon HIL in India and authorized distributor for few world-renowned companies working into education sales more than 38 years and was established in year 1982. And this is Mr. H.I. Siddiqui. He is the CEO of our company. He is very who played very major role in introducing its Typhoon HIL and its first product in India after it was globally introduced in 2008. Our first Typhoon HIL 600 series was successfully working at Amrita University in Kollam, and second Typhoon HIL, that is 400 at NIT, Surathkal, and so on. As the list is endless, but some of the lists are still included in this, like IITs, MNNITs, NITs, and NILETs, government and private universities. Our first microgrid testbed is installed in India, that is at IIT Kanpur in year 2018. Here we can see that there are three Typhoon HIL 604 boxes are connected and five HIL Connect, five Typhoon HIL HIL Connect, and one Typhoon HIL measurement terminal for monitoring the current and voltages. And HIL Connect, as we know that it is a true plug and play interface with the HIL Connect that gives us the feel just that we are working. It's an interface to LEM sensors as well. So it is the first microgrid testbed that we installed that has the capability to simulate 24 three-phase, three-level converter with time step down 500 nanoseconds or 450 plus IEEE standard node or bus system with loads and source. The second microgrid testbed that is installed at NITTR Chandigarh in year 2019 for a smart grid and electrical vehicle study. So here we can see that here also we have used the three Typhoon HIL HIL box 604 and one Typhoon HIL HIL Connect. Only the difference is that in microgrid testbed installed at Kanpur and Chandigarh is that here we have used the smart grid controller inbuilt communication protocol to exchange your data Modbus, and this is also has the capability to simulate 24 three-phase three-level converter with time step down to 500 nanoseconds or 450 plus IEEE standard node of a system with loads and source connected to the time step down to 10 microseconds. Here also we can connect our you can also connect your actual relay with your simulation using the relay connect. Typhoon HIL 604 6 series and code dedicated FPGA. This allow us to vary the interfacing and the experimentation. So there are no need of much worries here. These are some of the global customers with EPC Power and India National Laboratories and Freedom Systems, Schneider Electric, Inflection. These are some of the industries with we are working. And there are big names also like MIT, AIT, then Ayrton, ABB, Woodward, and Lincoln Laboratories, etc. are our pioneer users, and there are many more who are still in line and will be soon will be listed in this. These are the stages that how we go. Actually, this is I prepared from simulation testing, but if we do not know anything about this, if we are not, then we were not very much familiar with the progressive stages of the PC. Then what we did, we first used to have the hardware testing. So when we used to have the hardware testing, there was some drawbacks like we have very limited flexibility. We cannot have much more changes. We cannot use very much. Means, we cannot configure according to our needs, according to our desires. And if we are configuring, then we have to purchase each and each hardware part or component for that. That came to the financial loss. So this was the great loss for us when these three steps were missed. So as the PCs got progressive and so the technology, so we simulation had played a very major part here because it is an approximate imitation of the operation of the process of or a system that represents its operation over time used for performance tuning or optimizing safety engineering testing training and education. And when we say virtual, it means it operates on the platform of integrated software and hardware components, means that in this manner a system can accept input from the user, that is the physical controllers, and produce output to the user in the in the form of the display form. So now this is step which we used to do over the years back, many years over the decades, which we used to have the first step. We have now switched on to the advanced simulation technology. We go step by step. Here we do first the simulation testing. Then here we get the limited accuracy, but flexibility is more and more that we can change. Like for example, if you want to go beyond the rating below the simulation rating in simulation, like for example, induction motor at 2 ampere, the starting current can go up to 8 ampere. So all these flexibilities you can do while the simulation testing. But here we have the limited accuracy, but flexibility is more and more. But when we go for the real-time simulation, when we talk for the real-time simulation, that refers to a computer model of a physical system that can execute at the same rate as the actual ball clock time. So now the simulation is very similar to virtual. Only the difference is that after compilation, both plant and controller going to the process by a specific device called real-time simulator. I'll show you. This is the simulation part. Here, what we do first, we define the model definition that what we are going to do. We first define the mathematics for that. Then we do for then we go for the computer modeling. Then we simulate for solving the differential equation of the plant and mathematics of the controller. So this is the plant and this is the controller. Here we are using only one type of a processor. Means here you have the flexibility to work. Here you have the flexibility to test anything without any physical damage. Here you have accuracy and but it is non-real time. The difference between this simulation and this real-time simulation is that here we are going to uh, connect plant and controller, but we are using different processor, one for plant and one for controller. So this is the only difference between the virtual hill simulation and this real-time simulation, that after compilation, both plant and control are going to process by a specific device called real-time simulator, and in this, plant and controller are going to process by different processes. So there is a much more increased accuracy, and it is real-time, actual to the wall clock time, and no use of physical hardware we are using. This is HIL simulation. You can see here in HIL, this is controller hardware in loop simulation. Now here our plant is digital, and we are using controller as actual part. Actually, HIL, that is hardware in loop, Typhoon hardware in loop simulation, allow us to test real devices integrated with the digital system in real time, from testing all imaginable operating conditions through control system verification to automated process. This Agile platform provides us with all the necessary features to get our work done. And there are several ways in which we can have our work done in a very proper manner. That is controller hardware in loop. You can see that here plant is digital and we are using the actual controller part. So this is controller hardware in loop. These are the development stages. Now here you can differentiate that what is the simulation and real-time simulation and CHIL, then power HL, then full power test. According to the cost as well as the fidelity, how much comfort, how much flexibility you are going, and what is the result approximation and actual results you are going to get. Like for when we talk about this simulation, in this simulation you can see that we know we need only the simulation software. You can see that this is all these components surrounded by this red dotted rectangular. So this red dotted rectangular here, it shows that here we are using only one software, means only one single processor. We are using here only one single processor, but in real-time simulation, when you will go here, you can see that this is the two rectangular blocks. You can see these are the two red rectangular blocks. This shows that here you are going to use the simulation software plus real-time simulator, means plant by one processor and controller by other processor. This is the controller part. Controller is handled by one processor and plant is handled by other processor. Means here only we are using the real-time simulator. Now when we talk about, now you can see the cost. Here the cost was very minimized and fidelity was so, because here we are getting chance to have more flexible changes we can make. But in this you can see a cost has bit increased because we have used other processor for the controller, that is the real-time simulator we have used for real-time processor we have used, means real-time simulator we have used. So obviously your fidelity will be increased. But when we go through this controller hardware in loop, now you can see this red dotted lines. This shows that our plant is digital, and this controller part surrounded by blue rectangular lines. You can see that this controller part is actual. Means for HIA, for this controller hardware in loop simulation, you need simulation software, then real-time simulator, and actual controller. That is the actual controller, that is like a DSP card from Texas or Xilinx, like that you can have. So here you can see a cost is bit increased, and the fidelity has almost, means according to our desirable results, according to our desirability, we have reached our results. So I think this three step, this is much more popular nowadays. But for much more accuracy, if somebody wants, so you can also switch on to this power hardware in loop. This power hardware in loop, you can see that now here you can see that some part of the plant and some part of the plant and controller, some part of the plant and controller are digital, and some part of the plant and controller we are using the actual form. So obviously here the cost has increased because here we are using some part of the plant and controller actual, means here we are using the simulator, simulator software, then real-time simulator and power amplifier. So obviously the cost will be increased here, but you can see the fidelity is not much more affected. But at that point, here the fidelity have somewhat increased than this, but not much affected. Then you can go ahead with this full power test. Full power test means you are using each part of the component. That is the means all parts, means both plant and controller is actual. Both are actual. That is indicated by this red rectangular line. Now here the cost has increased very much and fidelity is approximately same as we have seen in this third stage and in the fourth stage. So these are the comparative methods keeping in mind which we developed a product here. And according to the use of the users, desire of the users, we try to give them a very nice product from our side, and as well as we try to give them a technical support even after sales and before sales. So this you can see that these are the development stages which I have shown through a one graph. Earlier we used to have this as our initial step, but now the scenario has changed. We are going step by step. So coming towards the Typhoon HIL technology, you can see that here, okay, let me discuss about a general simulator first. When we talk about the general simulator, then general simulator uses the technology based on the two processors, like based on Intel processor and based on Intel processor. I'm talking about the other simulators. Actually, I'm not here to preach which one is better or not, but for making our technology, that how our technology is very much best towards the other, I need to quote some points here. So here I'm going to tell that what is the difference, major difference. In other simulators, they are based on Intel processor, like they use CPU as their main processor with FPGA as secondary processor. But our Typhoon HIL technology use FPGA as the main processor and CPU as a secondary processor. In FPGAs also, there are two types of FPGA. Like for normal FPGA, there is a logical part provided for logical action, like RTX, Kintex, and Spartan. And for SoC based, like system on chip based, these are best to perform the logical. They have the ARM processor, it means Advanced RISC Machine, which is a family of a reduced instruction set of computing architecture for computer processor configured for the various environment. So the purpose of using these SoC-based FPGAs is to provide less delay and the less losses. Why we are using the FPGA as the major part, means as a main processor in our technology, there are several advantages of FPGAs over the CPU. I'll let you know this. Like a CPU is just a chip that is executing a program based on a specified set of instructions in a sequential manner, whereas FPGA is a chip consisting of series of logic blocks which can be modified and configured by the user. Actually, these FPGAs are ideal for the parallel systems, means where multiple tasks must be performed. Means this is just like a blank sheet. You can configure according to your use, but this flexibility is not available with the CPUs. But so this is the major advantage of this FPGA, that why we are using FPGA. First of all, it is ideal for the parallel system, and secondly, and it is just like a blank sheet. You can configure, you can determine the logic, but with the CPU, you have a fixed set of instruction. Means this has to be added by the programmer. Means the program itself can be changed multiple of times, but here, you have some bug fixes to completely change the program. So there are some complexities, means some complex things cannot be done in CPUs, like this time critical processing. This part cannot be done in CPU. In CPUs, these are not ideally suited for this time critical processing part, whereas FPGAs are capable of performing this complex and time critical processing even in parallel and other critical processing parts. Regarding some of the complexity, portable, both are portable regarding language wise, because here we are using in CPUs, we are using the C and C++ and FPGA code is written in a very long hardware description languages, that is VHDL. But on the opposite side of the spectrum, we can see that the FPGA is very much configurable and modifiable, where the user can decide that how complex the design should be. This makes them simpler and less complex to understand. Whereas CPUs are generally more complex as compared to FPGAs, primarily because they have already a fixed set of internal blocks and processors that are already being designed by the manufacturer. So here you cannot configure. So this is the advantage of using our this FPGA chip, means FPGA processor as a main processor, and using CPUs also as a secondary processor, because the best of these two cannot be gone. If we used to have the best resulting solution, that is with very much flexible efficiency in work we need, then we have to use these two combinations, combination of CPU's unit and FPGAs, by combining the two together as a single entity with features of both. Now, what these two parts are doing in our Typhoon HIL technology. Now, coming back to this figure, we can see that the CPUs, FPGAs are our main processor. So here FPGAs are, these are the multi-core based processor designed for time exact simulation of electrical domain models, and these solver executes models with the base simulation step. I'll tell you that how these FPGA solvers work in my later slides. Integrated with the industry's leading performance, this over 28 mm nanometer, programmable logic achieve power and performance levels. So this is the main work of this FPGA system. But here we are using the two CPUs also, like one is user CPU and other one is system CPU. System CPU, that is one or more general purpose processors that are indirectly controlled by the user. Actually, these are used to simulate the low dynamics phenomenon of this certain electrical domain components, or to handle the communication protocols and the stacks. Whereas the user CPUs, they execute the submodels composed of the signal processing components, means is these are multiple of the base simulation step, and user defined means these are under the direct user control. That is why it's named as user CPU. I'll show you its architecture as well. The user CPU, in user CPU, we are using the ARM. ARM, that is the Advanced RISC Machine, that is the family of reduced instruction set of computing architecture for computer processor. And in Typhoon HIL technology, we are using ARM Cortex A9 32-bit 667 megahertz 256 KB on chip RAM, 96 MB external RAM. And for system CPU, we are using the Microblaze soft CPU, that is it is used for slow dynamics, like to handle the electrical components like RMS values or single phase component sources. And because these Microblaze is a soft microprocessor code designed for Xilinx field programmable gate array. And as a soft core processor, Microblaze is implemented entirely in the general purpose memory and logic fabrics of the Xilinx FPGA. So this is the work of this system CPU and user CPU. Means in user CPU, it has the execution rate up to 4, and in the Microblaze system CPU, it has execution rate up to 2. So here you can see that this is the 4 series. For the 4 series boxes, we are using this. And for 6 series boxes, we are using ARM Cortex A9 32-bit 800 megahertz to 56 KB on chip RAM, 96 MB external RAM. So this is the system architecture which we are using in our this Typhoon HIL technology. And here you can see that FPGAs are working as a main processor. Now coming back to this figure. Here you can see that in figure I have done some coloring. The purpose of doing this coloring is that the components which are surrounded by these green rectangle, these are fully or partially simulated on a system CPU. So these parts which are shown in green color means these are simulated on a system CPU, whereas components framed by the blue rectangle are simulated on the user CPU. And all the remaining parts means all the remaining parts which are not colored, which are not surrounded by any of the rectangles on any of the color rectangles, these are handled, these are simulated on a Typhoon FPGA solver. Okay, so now this part is left. So let us see about this FPGA solvers. This is the FPGA solver. Actually, the purpose of the FPGA solver is that Typhoon HIL actually introduced a dedicated multi-core processor architecture implemented in FPGA fabric. I request guys to please mute your mic as well as those who have cameras on also for the smooth running of the session. So here Typhoon HIL has introduced a dedicated multi-core processor architecture implemented in FPGA fabric. So it is in order to understand the fundamentals behind the modeling principle, that what are the fundamentals behind the modeling principle and the constraints. So it is very important to understand this part, means this part of the FPGA solver architecture. So what includes FPGA solver? This FPGA solver includes these, you can see this is the SPC array. SPC's arrays means a standard processing cores. So this is standard processing core is nothing. It is a basic building block of the circuit solver, and it is in charge of simulating electrical circuits consisting of linear passive elements, both constant and time varying, converter blocks consisting of ideal switches, then contactor based on ideal and non-ideal switches. So
All are
these
requested to
SPC
please
blocks,
close their cameras so that we can save the bandwidth and we can means successfully means properly we can present the things.
so these
Sir,
SPCs blocks are, thank you sir, SPCs blocks are interconnected. So the purpose of this SPCs blocks is that these SPCs blocks are interconnected through dedicated communication lines, which allow them to exchange variables with a single simulation step delay. Remember this time varying, which I talked about, this time varying and non-ideal switches. These are means optional. Means these are optional. They may exist in all configuration. Actually, we are having different configurations for our HIL boxes, like for 4 series and for 6 series. Like for 402, we are having the 6 configuration, but in 402 we are having 2 configurations, so they are a different configuration, so need not to worry, you can change the configuration if you want to use this time varying and non-ideal switches. And there are further more like number of signal generators, or if number of machine solvers, these all depend upon the solver configurations. So according to the use of your need, you can change the configuration and you can use that. So I think all of you must have understood this, what is a standard processing course. Now, coming towards this lookup table, signal generator. This is the signal generator. It is in charge of generating arbitrary waveforms at the full simulation rate. It is mainly used for independent voltage and constant voltage and current sources. It employs linear interpolation in cases where waveform sample rate is lower than that of the simulation rate. Here also, again, telling you that the number of signal generators channels, it will depend on the solver configuration. Means the configuration in which you are working. According to your need, you have to change the configuration if you would like to have the experience of signal generated according to your use. How many number of signal generators you would like to use? So in different configuration, it is given there that how many number of signal generators you can use. For lookup table, it is a unit to simulate behavior of non-linear elements such as the PV panel, battery, and saturable transformer. So this again also depends it's how many numbers you can use, again depends on the configuration you are using. Then machine solver, it emulates a single electrical machine model, including its electromagnetic part, mechanical part, and the speed measurement devices such as encoder and resolver. So the how many number of machines solver you would like to use, according to your model, you can change the configuration and the number of machine solvers you can use to your comfortability. Similar for the PWM modulator, this is a multi-channel triangular PWM modulator, can be used both internally to drive internal converter models and externally through the digital outputs. It runs on FPGA internal clock that is typically 150 megahertz and features a built-in dead time generator. Again, the number of this PWM modulator you can use according to the configuration. Again, it depends upon the configuration. There is one advantage that with 20 nanoseconds PWM sampling time to 500 nanoseconds simulation time step, we are providing you the less low latency, means very low latency we are going to get, means there is not much delay, you are avoiding your complete delay. But remember, see, latency is a factor which depends upon the sampling or uncertainty. Like it depends upon the hardware characteristic and software setting and model itself. But we have the extensive feature, means very a unique feature that with 20 nanosecond PWM sampling time and 500 nanosecond simulation time step, we are providing ultra low latency and has set the industry standard for ultra high fidelity real-time emulation. These are the series of the simulator boxes you can have the experience, the series which we are having. We are having the 4 series boxes and 6 series boxes, then M series also we are having. So in 4 series we have 4 core dedicated FPGA. Okay, 4 core dedicated FPGA, 4 3-phase 3-level converters, simulation time step down to 500 nanoseconds. We can have, and for 6 series we can have 6 3-phase 3-level converters, simulation time step down to 500 nanoseconds. For 602 plus and 8 3-phase 3-level converter simulation time step down to 500 nanoseconds for 604 Typhoon HIL HIA 604. You can see these hardware boxes. You can identify that what we have used in model. Like for 402, you can see here are 2 interfacing ports are given. And here also 2 interfacing ports are given in 602, here 2, and in 604, 1, 2, 3, 4. This is how you can identify the boxes only by seeing the boxes that which box we are using. Okay. Now, number of single phase converters you can use, that is 12 in for 4 series with simulation time step down to 500 nanoseconds. And for 602 plus, you can use 18 converters, simulation time step down to 500 nanoseconds. And for 604, you can use 24 converters, that is simulation time step down to 500 nanoseconds. The number of IEEE standard 3-phase buses, that is 80 plus buses, simulation time step down to 10 microseconds, you can use for 4 series, and 120 plus buses, simulation time step down to 10 microseconds, you can use for HIL 602 plus. And for 604, you can use 150 plus buses, simulation time step down to 10 microseconds. And controller part, that is ARM Cortex A9, which we are using, user CPU microblade CPU for low level and high level controller simulation is eligible for all the series. Even you can have the multi-rate simulation for all the series. Remember, in 4 series, 402 works standalone, whereas 404 can be cascaded, and 6 series devices may work parallel, and it can be cascaded up to 16 devices at a time. Okay. This is a major difference you can see between this 402 and 404. You can see that in 404 you can connect up to 4 HIL 404 devices in parallel. You can communicate with other real-time devices. You can interface via Ethernet, CAN, RS-232, then GPO, then HSSL, then JT edge, all these you can interface with them. These are compatible. Only the major difference is that 402 is using zinc 7 SoC and 404 is using zinc ultra scale SoC. Rest of the input and outputs, that is 16 analog inputs, 16 analog outputs, and 32 digital input and outputs are common for 402 and 404 as well. Built-in scope is probable for both. Connectivity, you have seen that here you have the different connectivity measures. You can opt for different options for 404, but with 402 you can have only the two. Then here you have the power, that is this is power, that is 12 volt 5 ampere adapter, eligible for both. Then housing you can see, then compatibility with HIL DSP interface, then HIL DSP 180 interface. This is uh, the thing. But in 402 we can go up to 6 configuration, but in 404 we can go up to 2 configurations. Also the advantage of using 404, that like in 402 we have input output rate or resolution is 1 microsecond for all, but in 404 there is option for 0.5 microseconds also. If you want to work for 0.5 microseconds, that is input output rate or resolution, that is 0.5 microseconds for 404. You can do that 404. Coming towards the 6 series, here you can see that in 604 we can have the 602 plus, we can have 16 analog inputs and 32 analog outputs and 32 digital input and digital outputs. Whereas in 604 we can have the 32 analog inputs and 64 analog outputs, 64 digital inputs and 64 digital outputs. Built-in scope is eligible for both. Connectivity, you can see all the most is common, only one is differentiated, that is this is time synchronization. Here you can have this option eligible. And power, you can see this is according to the 110 volt is given according to the American standard and 240 volt according to our standard. So in order to match this international standard, this power is given in range between 110 to 240 volt, 50 to 60 hertz. So don't confuse with that. So it is maintaining the international standard. The housing is shown and the compatibility with HIL DSP interface, HIL DSP 180 interface, HIL breakout board, and HIL DSP interface. Both are compatible with all these. Now again, here you can see for 604, you can identify 604 very easily. 1, 2, 3, and 4. If it is shown in built-in microgrid test bed, you can easily see that how which box is used, either 604 or 602 plus. Okay, so this is a Typhoon HIL microgrid test bed. It is a collection, means it is a collection of this HIL devices with integrated protection relays and microgrid controllers and solar inverters, battery inverters, diesel gensets, fuel cells, etc. Here you can see that these here we have used two HIL. One box is this one box, one Typhoon HIL box. This is 602 plus. Other Typhoon HIL box, that is 602 plus. Then we have used the battery energy storage system, that is inverter controller. We have used the solar inverter controller used for PV, wind application, and for renewable energy resources. Then relay connect by SEL. We have used the two relay connects used by the SEL and relay connect designed by the ABB. Then diesel genset, Easy Gen 3000 is the name of the diesel genset controller. We are using from the this is from Woodward's, as Woodward is a pioneer in diesel genset controller development. So these devices can be customized according to the need of the user. Okay. So the main purpose of the microgrid test bed is to comprehensively test and validate primary and secondary control and communications and protection under all operating conditions, including faults in both the islanded and grid tied mode. And moreover, means this can perform all test and generated test reports in the fully automatic mode, thus boosting the productivity and improving the test coverage even further. This is one of the case study for the microgrid test bed in Massachusetts Institute of Technology. This is the Lincoln Laboratory, and here the microgrid controller design has been done and it has been tested. So here you can see that what we have used here, the diesel genset, then natural gas CHP, solar plant, then battery energy storage, inverter controller has been used, then microgrid, this controller GE18, then two genset the controllers, the diesel genset controllers means from Woodward they have used, solar inverter controller, then simulation time step is 2 to 4 microseconds means multi-rate, and 4 HIL series, 6 series boxes they have used, and protocols which they have used, that is Modbus, TCP and UDP for data logging. So this is the microgrid controller design and electrical test design and testing in Massachusetts Institute of Technology. This is the further portfolio of the tool chain. See about the microgrid test bed, the multi-hill system architecture parameters are very vast. So according to the use of your things, you can use like for 602 and 602 plus means maximum number of devices in chain. For 602 plus you can have 4, and for 604 you can have 16, and for 404 you can have 4. And the number of electrical variables that one SPC can send to and receive from other SPCs and other devices for 602 plus is 8, and for 604 is 8, and 404 is 8. So these are the some of the configurations are there. In fact, also you can have the maximum number of signal processing. For 6 series, you can have 602 plus, you can have 16. Then 4 series, you can have 16, and for 604, you can have 16. Maximum number of signal processing variables per stream, and this one is. Also for the electrical variables that one device can send it to or receive from other devices, that are also 16 for all. Okay, so these are the simulation time synchronization you can do for all, and all can be synchronized. All the parallelized HIL devices are synchronized with master HIL, that is one with the ID 0. Actually, I'm using the word ID 0. Actually, here we start counting from 0. When we use, like if I'm using 3 devices, then I will count device ID 0, ID 1, ID 2. So these are the 3. Means here we start counting from 0. If I'm using 2 devices, then I will count device ID 0, device ID 1. So don't confuse. If it is showing device ID 0, it means you are connected to one device. Here you can see that is virtual hill is tool chain for all series, for 4 series, 6 series and M series. Then paralleling of HIL devices, that is for 4 series, 6 series and M series. Then HIL processor, we have used PC for all for virtual hill. Then Typhoon HIL cores, you can see that in 4 series, you can use up to 4 cores, and for 6 series up to 8, and for M series up to 80. Similarly, ARM you can have for 4 series, that is 2, and 6 series 2, and for M series it is up to 20. High speed input output, you can see analog input, that is 16 for 4 series, and this is the maximum number we have written. This is up to 64 for 6 series. Already in different in the comparative table already told you that for 602 plus and 604 up to 640 we can use here for M series. And for digital input and digital output, here we have 32 for 4 series and 60 up to maximum 64 for 6 series. and M series for 640. Then communication protocol, that is internet IP, that is Modbus or IEC 61850, that is for virtual hill. Then for 4 series we can use this Ethernet, IP and Modbus, and for 6 series we can use all these communication protocols, and for M series also. Then for maximum grid size, for 4 series you can use up to 60 nodes, and for 6 series you can use up to maximum up to 160 nodes, and for M series you can use up to 1600 nodes. This is the interfacing boards which we can use with when we are customizing, like for HIL connect. This is the HIL. This is the H. Sir, please mute your mic, please. This is the HIL connect, Hill connect, that this is for used for measurement, and it gives you the feel that you are connected to the real controller. It gives you the feel. So that is the purpose of using this HIL connect here. Then it can directly interface your controller to the HIL emulator. Then it can connect interface that means for any power electronics controller to the Typhoon HIL family of real-time emulators, and its modular signal conditioning architecture enables our engineers to rapidly customize to match the industrial controller input-output interfaces such as current sensors, voltage sensors, fiber optic transceivers, then contactors and temperature sensors, and many more. For breakout board, it is just very similar. It is done wiring by wiring as we do on breadboard. Everyone is familiar with breadboard. So as we do wiring on breadboard, the similar way we can use the breakout board. This launchpad interface or DSP interface, DSP interface and launchpad interface, that is for TI DM100 DSP cards. This is the way to go for those who want to accelerate the development of power electronics applications. For Texas instrument families of DSPs, Typhoon HIL emulates power stage of a power electronic device that include power converters, electrical machinery filters, then electrical grid, PV panels, passive elements, etc., with 1 microsecond overall time resolution. In this way, the user can develop and immediately test their control applications without worrying about the safety measures are required in the power laboratory environment. So this is the purpose of using the Launchpad and DSP interface board. DSP interface boards, that is, this is a socket for TI control cards, and it is available with converter card. Means it interfaces one card. It can interface one card, but with microgrid DSP interface card, it is um, actually with the increasing demand of for microgrid development tools using Texas instrument families of DSPs. So here we have the microgrid DSP interface card. Here you can interface 3 cards. It is a here you have it is also available with the converter card. Here you can interface with 3 cards. Here you can interface with 1 card. So this is the advantages of the Typhoon HIL process, means how it is compatible. Like there are a number of steps are used while running the simulation. First you have worked out for the mathematical, then you have designed the model. Now when you have designed the model, then you have to generate the code. But here the code generation is automatic. This code generation process, this code compilation and code loading process is handled by the Typhoon HIL process. You need not to worry. Here we are using the inbuilt systems, means inbuilt inverters are available, inbuilt rectifiers are available. Only you have to fetch the component from the library. So this is reducing your time. This saves your time. Even the compilation time is less than 1 minute for the very complex model which takes 15 to 10 minutes in other simulators, and thus it makes easy to use. Easy to use in the sense means it is very user friendly, and you can have the better experience with this, because most of the part is handled by the automatically done by this Typhoon HIL process. Also, you have the flexibility of using different things here. When you will go through the libraries of this, you can have the better experience. Okay. This is the controller hardware in loop, already mentioned there. This is where the controller part is actual, and this your hardware means plant is digital. This is one of the case study. This is the case study in this Anurag drive. Here you can see the case study shows that here they have used the full laboratory setup. Full laboratory setup they have used. You can see this is the control cabinet, then converter cabinet, then filter cabinet, then this is they have used 700 kVA, then means for transformer. 700 kV BSI used for transformer testing, and these are the results when they have used means full hardware setup, means full power testing, then they have used. So these are the results. These are the results when they used HIL 400 based setup, means only they kept the controller part as actual, means here you can see this is a part of controller hardware in loop, only the controller part is actual, and rest all these parts, that is converter part and filter cabinet and other parts, are replaced by our HIL box 400. So now 400 is not available with us. It has been modified to 402 and 404. So these are the laboratory setup results, and these are the HIL 400 setup results. You can see there is no difference at all here. The same results we are getting while using the full library. Here only the cost is high, but fidelity is maintained in both the cases. And here the cost is very much decreased as we are not using the full hardware setup. So here we have also got the compliment from the Andreas Dietrich. He is the CEO of the Anurag Drive. He said that Typhoon HIL emulator with OEM controller makes an ideal development environment which combines real control signals in real time with real hardware, which is as easy to operate as software simulation package HIL must have for every power electronics engineer. I thank to Andreas Dietrich sir for a very nice compliment for us. This statement, the purpose of quoting this example here of the case study, just only to differentiate for the results between the laboratory setup and the HIL boxes setup. Means the fidelity is maintained, fidelity is as expected according to the user. Again, here I'll say that I'm not here to preach that which platform is much more better. According to the users, every platform is better, but how our technology is very much better than other simulation platforms, this is only I'm going to tell here. That here we are providing both software and hardware from the Typhoon HIL. So here it is, you can say that this is a vertically integrated, no use of third-party software. Here we have the complete forward compatibility, which is means you can if you like for our current version is going with 64-bit, but if you have 32-bit, then you can switch on to the older versions. If some facility, if according to your use, some part is available with our older version, you can switch on to the older versions also. That are also available along with the latest updates version of the Typhoon HIL. But this compatibility is not available with other platform, means you have to be compatible with only the selected version. So here the compilation time is also less than 1 minute, as we are using the FPGAs as the main processor and CPUs as the secondary processor. And in other platforms, they are using their compilation time is more than 15 minutes. The purpose of using the FPGA means based from the entry level, the general purpose CPUs are used for the slow dynamics and other for used for the entry level and logical, and we can configure also in FPGAs. This improves our the compilation time. Here our simulation time step down is down to 500 nanoseconds, but in other platform it is 10 plus microseconds. In our digital sampling resolution, our Typhoon HIL is 20 nanoseconds, and on other platform it is 100 plus nanoseconds. It is here we are having the embedded HIL, means hardware in loop, along with the embedded Python 3 version. And here there are multiple vendors and multiple tool chains, means for each of these steps you have to go, like for hardware one shop, then for software another shop, then you have to make the match the compatibility features, then for significant resources also you have to look here. But here it is one stop shop. You can directly log into the website and you can directly fetch the details for all, and you can connect with us directly. Even for the technical support also, we always welcome that for any of the technical support or any suggestions according to your configuration, we are here to help you out in any of the manner. That's why we can say that here we are one-stop shop. So this makes us unique from others. For this, it is means we have the Typhoon HIL control center, then customize means custom test interfaces, then automation with Python. Then we have the several features of pre-certification. I'll let you know when I'll switch to the software installation part. There I'll go one by one. I just switched on to the software part. First, I will let you know that how to install the software. Only you have to go to the Google, just type Typhoon HIL. Here your Typhoon HIL homepage will occur. When your this Typhoon HIL homepage will occur, just click on there. Then if you want to check the products, you can check. Here it is the products. So here it is software tool chain is available. Then devices, for devices I'm clicking for virtual HIL device for installing the this software. Here it will ask get your virtual HIL license. Just click on here. Now here one sort of a form will appear. Just fill this form, your name and your everything, just submit it and put the mail ID correct, because you will be receiving the activation key from the Typhoon HIL admin to your mail ID. When you have completed this form and when you have submitted, then you can go to this. When you have also when you have received the activation key in your mail ID on your the mail ID which you have provided, then go back to the here my Typhoon. When you will go to the my Typhoon, you can log in here because registration part has been already done. See, already I have the activation key, so I need not to put here. Otherwise, a short form will come where you have to give your username, then you have to set your password and activation key which you have received on your mail ID that you can use. Now here I'm logging here with my mail ID. One second, there's something I put wrong, I think. Oh, caps lock was on. Yes, see. Um, so this is the when you have login, then this type of a window will appear. So here we are right on subscription. From here you can download your license file and you can save where you want, because when you have installed the software, then it will ask to import the license. So just download the license file and you can import the license where you have saved. See, my activation key is here and it will also show the status whether it is active or not. Okay, then here, remember, simulation with Typhoon HIL is free of cost for unlimited number of users with lifetime free updates, and real-time simulation and controller hardware in loop is on cost with lifetime free update of firmware and software for unlimited users. Okay, so for this virtual HIL, you need not to pay anything. Now you go to the download option. Here you will get the two options. If you are a Windows user, you can directly switch on to the Windows. You can click on here and you can download it. And if you're a Linux user, you can directly click on here and you can download it. Here you can see the library compatibility and the installation means from version, how the procedure of the changes. The best way you can go, that go to the documentation. As a new user, if you're using, go to the Typhoon HIL quick start. So here one document will open. See? So here you will get how to start each and everything if you are a new user. Here you will let you know that what are the system requirements. You can see that Typhoon HIL software system requirements are Windows 7, Windows 8 and 8.1, then Windows 10, then minimum 2 GB RAM, then minimum screen resolution is 1366 into 768, and all other dependencies are included in Typhoon HIL Center. Now you can download the software. After downloading the software, you can, this is the process how you can log in. Already I told you on the Google window. Then here so when you this downloading part is done, when you have you can see that software download is there. Download page will come. On this you can download the Typhoon HIL software in appropriate dependencies. This activation key part we have done. See, this part will come when you have received the activation key in your mail. Then you will receive this. Then as a new user, you can go to the My Typhoon and there a page will come. There you have to fill your email ID, then password, then again password, your name and the activation key which you have received on your mail ID after the registration part. Okay. Then you will get such type of thing. It will show that your account has been activated successfully, and from here you can directly click to start this work. Then how you can do the software installation. When you have downloaded the software and when you have to install the software, then it will show that to click here if you would like to select a different folder, means just click here to select the folder where you want to install the software. Also create a shortcut for this Typhoon HIL Control Center on the desktop. Then you can do it next, and it will complete the Typhoon Hill Control Center, and here you can click the finish. So here it is showing that it is installing Typhoon Hill. Such type of a window will come, and it will be doing the installing process. Now here it will show that it is unable to detect any hardware part because you are not connected to hardware, so it will show it is unable to detect hardware. Okay. Now here the license file which you have downloaded and saved to your desktop. From here it is showing that import license from where you have saved. When you have import the license, then this option and this window will not come. Until unless you have not completed the license part, it will show that the license file is missing, and if it is completed, then it will show that you have the license completed. Then you can restart your Typhoon Hill Control Center, applying the new license which you have already done. You can also change the license, like for actually for a different according to the use means we are providing the general license, but like for example if you need to go for a test suite demo, so there should be an additional license. So for the additional license you need to change your license, so you can change the license. You can start the Typhoon Hill Control Center, you will click on the license, then change license, then enter the activation key, the new license will be automatically applied. This will status show for the active license and the license which has been expired. The firmware update, we need not to wait for the firmware update for months. It is updated automatically with the software. As the software updated, the firmware update is automatically updated. You need not to wait for 6 months or how many months like in other platforms. So here it will show that like here, if some update will be available, it will show in firmware status, and if it is up to date, then it will show like this. So now with these steps, we can complete our this installation and the software. Now coming towards the software window, this is the software window. See here, the license details are showing. Okay. This help icon is given. If you need any online help, you can have the online help. But this this help icon will only work if you are connected with the internet. Hardware info. I'm not connected to any hardware HIL box. Means any hardware box. I'm not connected, so it will show unable to detect any HIL device. If it is available, then it will show that you are connected to HIL box such and such. And so on, you can get the refresh. Okay. This is the version. By clicking on this version, you will get the total highlights of the version. That according to the latest version, what are the changes we have made. This will show. Like in this version, you have the added support for spatial harmonic models in a permanent magnet synchronous machine. You can also, this is also available for now Linux too. So this microgrid library extended and generic diesel genset and wind power plant models also. This is added support for forward voltage drop modeling. Then external C code generation is now officially supported. Then this is also added support for simulating JM, RT, LDLQ model type permanent magnet synchronous machine. These are the general, that is CPU support for HIL 404. Then these are the latest updates which we give. You will receive the quarterly updates along with the updation of the software automatically. This is unlimited for unlimited users, and these are the several other libraries which are now officially supported in a schematic editor, like external C code generation, then new components like diesel genset, wind power plant, then multi-pole single throw contactor, dynamic table, then split source inverter, then library components, all the converters support the model control, then open winding option, then TLM coupling in RL section, then forward voltage drop, then permanent magnet synchronous machine with silent rotor. So all these are the library components upgrades which we have upgraded in our this latest version. Then PSUs, that is for in HIL SCADA. Typhoon test IDE, this is an added option to stop HIL simulation on stopping of the test script. So these are the upgrades are available, and these are the you can see here. So this is how when you click on the version, you will get all the details regarding the firmware as well as with the software that and everything that what you need to what is updated. Similarly, if you have downloaded the older version, you can compare according to the requirement. You can go ahead with the versions. Okay. Now coming back to my software window. This is the schematic editor. I'll come back to this part later. These are the additional tools, like in test and calibration part. I'll start with this test and calibration part because rest of the things are a bit much more lengthy, and when we will enter to the software part, then we will discuss. So test and calibration part, if there is any problem in the hardware, till now we have not received any such problem, you can directly report or mail, and there you can have the additional license for this and for the test calibration part. For test suite demo, it is a pre-certification. I will show you in when I will open the schematic editor, then I will show you about the test suite demo. There are several test suite IDs for this microgrid as well as your this is the advanced version, means we can do for pre-certification. Test ID is nothing, it is only advanced version of this Typhoon HIL test. So here you can have for test suite demo, you can have the like for microgrid test bed, you have the BD, EW, FGW, then TR3, REV23, then for MPPT, that is AIT, ISORIP, that is need for small means for this is a pre-certification tool according to the international standards which we are using. Means after using this, your means then you have performed and you can go for the test suite demo before going to the verification of the international standards, because we are following the international standard. So 99% your project or your work will be accepted directly after when you have undergone through this pre-certification. You need not to worry. So this is just to save your time and just to check whether you are in the right direction or not. Okay. Then coming toward this waveform generator. This waveform generator part. In this waveform generator, you can have like this is to model your PV panel. Like if you are having the PV panel, if you have purchased any PV panel and if you are having the details from the manufacturer, you can directly fill all these details directly from the manufacturer if you have the manufacturer details. This is the irradiance and the temperature. You can keep it according to your will. Then if you are not having the manufacturer details of the PV panel, then you can select, you will be told, then you will be working with that. So here you can select the model. Okay. And here it is also option of allow negative current. So here you can see, just click on the preview button. Here you will see this model. When you will fill this EN50530, it will already fill it all its detail. Okay. And if you want to generate some PV curve, you can import also. You can import any of this. So this is also the flexibility that you can import the IV curve also. So this is the work of this PV panel. In source file generator, you can have this. You can see the time step or time unit. You can have the changes. You will all go all through when you will be doing the hands-on modeling. Then you will be done. From here, I can choose any of the source input file. Here you can provide spikes, harmonics. These are the libraries which you can do like this. You can change it. You can have the, okay. You can sag it, swell it. You can provide the spikes. All these part you can do in this source file generator. Okay, this is the purpose of providing this additional tool. This is waveform generator you will be doing. Okay. Signal analyzer, you can analyze the signal, provide it in script editor part. So here you can see that there are windows available, 3 windows. This is a script editor where you can write the script in test. Here it is console. Here you can write, means here you will receive the message. Like for example, if I write area for the program of area of circle, then here I just put simple program. Then area equals okay. So here you can have the program for area of circle. Define your pi equals 3.14. You can also use this termination. Actually, here you can see that we are using the embedded Python. Either you can use this termination colon, or you can dismiss also using, that doesn't matter. Then print area. Now here you have to run. When you will run, it will ask for saving. So just save it. Desktop area. I just save it. See here the script is running. Oh, here I forgot to put the inverted comma. To put the braces. So if there will be any error, it will show here that this is the error you are getting. Otherwise, if no error, sometimes it shows in syntax error. Now here it is asking the value of R. I put the value of R. This is 5. And when I put the value of R, then it is giving the result 78.5. Similarly, this is the API wizard. If you're not able to view this, you can go to the view and you can take this API wizard. So you can load any model available, like I go to for this okay. Sorry. In the directly you can load model from the API wizard in this. API, that is automatic programming interface. See, you can directly load the model. I delete this and you can directly insert using virtual hill, then do it insert, it will show. Similarly, you can also load the setting files in the same manner. Okay. So now I am closing this script editor part. Coming back to my this slide, as I need to tell you the most important part here. So if there will be any software update, I've quoted the example. If your software update will be available, it will show from here the green icon. Okay, green icon will show if there will be update, otherwise it will not show. What is the update? When you will click, this will show. You can check for the update. This I already gave you the view, which you will be doing in further. This is embedded with Python. What is the role of Python here? Actually, for working with Python, there are several easy factors. Like Python is a very extremely good language at all being purpose programming languages. Again, I am here only to tell the specific beautiful features of Python. It doesn't mean that other languages, in fact, C and C++ and Python both works well together. Like for engineers, there are several of tasks like the testing, data collection, or automation, which constitute a large chunk of time. So in order to save this time, you can directly have this, you can use this Python coding. You need not to learn the Python coding because already it is embedded with Python 3. So you only have to insert the, already I told you that in I made you see that in API wizard you can directly do it. You can directly insert the code, so you need not to learn much about this, but you must have the basic idea of this. Okay, so there, so the 90% of the things like is consumed like researching or protocols or this. So here our simulation engine is this Python. Now from here, the web server, it is the Django, and here you can have the, you can save your file in the form of .csv. Then here you can have the waveform plot, plots. You can save it in matplotlib. Means it is really automated. There is a like for if you want to have any result like for the running waveform, if you want to save the data like from digital oscilloscope, then what you will do that first you will get the trace of that waveform, then a particular time you need to have. But with this you need not to have worry. You just go for and you can just save it in the .csv format. You will get the exact data along with the trace of the waveform. You will get the data also, that at what time period, at what frequency the waveform is changing. So it is just like you can have that is it is a Swiss Army life Army knife language. Already Typhoon HIL is from GmbH Switzerland. So it is a also you can switch to github.com if you want to have better access to power system and other. You can log on to the github.com, so from there you can have the different accessories. You can also use your system Python. If you have already installed in your system, you can change from the option where it is given embedded Python. From there you can change that if you want to use your system Python version here, but in our Typhoon HIL, we are using embedded Python version, that is 3. So with the use of this, you can uh, go ahead with all the researching, testing prototypes or debugging or creating test jigs or programs or production tests or quality control, and of course, the dreaded documentation, which is very hard to work out. So all these things can be done with this. So this is the part which is we can do. This is the test suite demo I was telling, that is you can pre-certify. When if I'll get time, I will show you on a schematic editor as well. But otherwise here you can see like that you will go. Then for test suite demo, for this you need to have additional license or special license if you want to perform the test suite demo. That is you can pre-certify your power electronic controller, like you can see for this MPPT, then MPPT, AIT, ISORAPE, then for this microgrid, this is VDW. And here you can go for the help icon also. You can click on these all, you will get to the help. It is showing that whether it is active or what the actions you need to perform. You can directly perform from the action widgets here provided. So coming towards to this, I just switch already the installation part we done. We come back to the our Typhoon HIL software window. Coming to the schematic editor part, when you will click on the schematic editor part, you will get this type of a window. Actually, we are already working on some. So this files already which we have used recently files, all these will be mentioned here, the recent files. But if I want to, you can go ahead, you can directly open the example model. You can go ahead. These are the several example models are mentioned for each field, like for basic electrical circuits, the communication protocols, then general power electronics and hardware in loop or power system or power supplies. Like I click on one, you can, I click on one. So here you can select any one of them and you can open it and you can directly go through this. Okay, you can open any of the model, okay, and you can study and you can directly simulate it and you can see the results. Now from here, this is the model initialization step. Here we initialize some script part if it needs to be done, like for execution time rate, or if we are to, if you are to provide some values for the capacitor or inductor, and if it is for valid, so there we assign in model initialization step. This is compile. When you will compile, the message console will show whether the errors, or if you're not having the errors, the validation will be passed. Otherwise, you can directly load model to the HIL SCADA with this icon, compile and open reload model. Okay, from here, now from here model, you will get this schematic settings. Okay, I just go to the new model, then it will show the library. Now it will ask that whether it is hardware product, it is 402. I'm okay with 402. You can have the number of configuration according to your need, ease of use, you can choose. Now this is the device table, means the device table, it is 402 you are using. So it is given that in different configuration what you can use, like in configuration 1. You can use number of SPCs only 3, but for machine solvers 1. But with configuration 2 and 3, you cannot use any machine solvers. For lookup tables, you can use 8 lookup tables for configuration 1, for configuration 2, and there are 6 configuration available for this. See, there are 6 configurations you can see. So these are there given that PWM channels, how many you can use according to your requirement. Non-ideal switches. See, non-ideal switches are available with configuration 3 and 4, but are 0 in configuration 5 and 6. With configuration 5 and 6, you cannot use the non-ideal switches. Even time varying elements, that's why I said that some of the components are available with the concerned configuration, not available with all the configuration. Like with configuration 3 and 4, you can use this time varying elements, and with configuration 5 and 6 you cannot use. So it will show in gray color when you will be opting for this option, and if it is eligible then it will show in black color in your library. So you can check the configuration according to your use. So this is the device table. Now it is exact, okay, then it is you can do next, finish. I will just quote a very simple example to know you that what is the work of this model initialization. It will take a few minutes because today I am opening for the first time. And several other things are also going on. You can work with the software offline as well. Okay. Till then it is opening. I just let you know with some more of the features of this Typhoon HIL, like on this when you have gone. So here you can switch to the documentation part also. I'll show you the documentation part. Now, when you will go to the documentation part regarding the software manual also, you can have that what are the things available in software manual. Then here is a schematic library, then HIL series, then code. Means even if you want to use the technical notes in your research papers, you can use the things from here. Okay, you can have the experience from here also. This is also available with the software part. There also documentation hub is given. See, here it is given, the documentation hub is given. You can open, and you can open any of these parts if you have the installed. If you are not using the net, and you can directly, all these material are available, you can directly study also without using the net, directly from your software also. Okay, help icon will only work if you're connected with this. See, this help icon will open, and this will display all these things regarding, like for test calibration tool, what you want to do. This is all given. It checks for problem for the entire device, digital input, output. It will all show. It is all the information is giving here. In fact, for Typhoon test ID also, signal analyzer, like if you want to go, so it is given. It is a tool for visualization and analysis of signal data. So before installing the software also, you can go through this guide available on the net also. Otherwise, after installing the software also, you can have the experience. But this help icon will only work if you are online connected. Otherwise, it won't open. Let's see whether my window has opened or not. I closed some of the things, I think. I'm closing it and reopening it once again. Sometimes it happens if there are a lot of things on your clipboard. So it is not a matter of worry. But till then, I can give you the preview of the schematic library. That in schematic, what are the things you can do? You have the library for passive components, then sources, then measurements, then test suite, then converters, then machine, then transformer and transmission lines and contactors, circuit breakers and circuit partitioning components are also available. Then signal processing components are available, interface components, and microgrid, and some of the additional components as well as signal streaming, C function, advanced C function, PWM modulator, Modbus service, Ethernet variable exchange, then Spec, then CAN bus protocol, then CAN open protocol. All these things are available. In fact, DTV detection, serial time synchronization, importing power losses. So schematic editor is one of the essential tools with the Typhoon HIL software chain that is designed to help you program your test equipment graphically. You can simply draw your power circuits with the distribution network together with the control logic and deploy them in uh, less than time, and you can draw a distribution network together with the control logic and deploy in a very less minute with a state of the art embedded compiler. In fact, from single converter applications and basic controller prototypes to multi-layer distribution networks, schematic editor will help virtualize your power system with ease. So this is designed to be a single windowed environment for all the modeling tasks, and all these selected text boxes and user-specific libraries are seamlessly integrated across entire tool using the use means using your this means all the modeling toolboxes from the libraries, and you can use it. And regarding the Hill SCADA part, here it is given. In Hill SCADA, when you can initially control and reconfigure your HIL test bed on the fly. In fact, you can visualize the results and build test procedures with Python programmable actions buttons. Simply drag and drop a wide range of user interface and elements to create your own interface for all the interactions with the HIL bed. You can freely arrange every single UI element in HLSCADA, resize it, and program it. You can also enjoy complete freedom in how you monitor your simulation and how you interact with. Okay. So you can do, and you can also customize the actions while using widgets from the Hill SCADA library. From Hill SCADA library, you can directly customize the widgets. Like if this is the Hill SCADA library is given, you can use any of the action widgets, and you can use, like for example, I just open one model. You can just have the uh, experience of the panel. It will just show that you are physically connected to some panel. Here there are some of the sliders given, knob is given for changing the values of something. You can have the digital display, you can put LED, you can using for contactor to show on and off, then capture and display for the waveform, then for data logging is also given, signal data logger, stream data logger. All these flexibilities are given. Okay. Okay, I think my script editor is open somewhere. So this you can do with this. Okay. Till then, if it is taking some time because the script editor was open there, we can have the. You can also log into the this Hill Academy part. Hill Academy is an online learning tool for us. Okay, this is the HIL Academy. This is a platform where you can find all the courses from every domain, and you can have the platform here. You can go for these are the specialist course provided for ECTS. ECTS means it is provided means according to the European standard. These are the number of hours provided. So there is nothing much for this. So these are the number of hours provided, and these are the courses you can do according to the ECTS means 28 hour. One ECTS equals to 28 hours of study according to the European credit transfer system. ECTS means credit transfer system, and ECTS is designed to make it easier for students to move between countries and to have their academic qualification and study periods abroad and recognized. And this is a tool of European higher education area of making the studies and courses and most transparent. So according to your time, you can switch on to any of the tutorials. Okay. So this is how you can log in, but you have to register it fresh. You cannot use your Typhoon HIL ID or password. These are the virtual HIL laboratory series which we are going to start starting very soon. There are 5 experiments, 5 days experiments and labs are there, and like basic electrical engineering, the network lab, then your power electronics lab, power system lab. So these are the labs. This is open to all BTech and MTech students and faculties. So when it will be started, and information will be mailed to you, you can register and log in. And also you can, for more details regarding this, you can switch on, you can log on to this website, or you can mail us at these mail ID is given. Hill.support at the quartz.com. Here you can mail even your technical queries or any commercial details. Also, you can contact us on hill.info at the rate quartz.com. I don't know why it is not able to open. So here you can do. Till then, I'll just show you how to log in on Hill Academy. Yeah, it's there. So here I'll just fetch one component consonant. You can search. These are the libraries given, like in circuit breakers, you can see double pole, then communication protocols, you can see, then contactors. Okay, I just close one by one so that I should not confuse when I'm using one simple model to show you the. This is the converters library, and it is very vast. It is inbuilt library. You need not to worry. You have to only fetch the converters according to your use. Then machines, you can see this is inbuilt machines are also available, like see. Okay, so this is you can use. Okay, then this is measurement part. Then in measurements also you can see here it is voltage measurements. Then microgrid part, also grid meter, then model partitions, then passive elements, then like capacitor, conductor. See, these are variable capacitor or variable inductor, variable resistor. These are shown in gray color. It means this is not available in configuration 1 I'm using. This may be available in other configurations. Okay. And then for signal processing, you can have the ports, means the signal input port, then signal output port. And for signal processing, you can have the discrete functions and logic table, then mathematical operation, then sync and sources. Okay. So all these things you can have here. These are the sources for the control part, then for system. Okay. And then this is a test suite demo, like for test suite demo, if for grid simulator, it is there. So you can use it, and you can Also click on this here, it will show all the means components like this. Okay, so this way you can have. I just close all. Okay, I delete this also. Now I will fetch one constant source that is okay. I'll fetch one constant source from here. Signal processing under. I will fetch one constant source. Then one gain I'll have. Gain source I will get from mathematical operation gain, and one probe I'll need to have. If somewhere like if you're not able to find the, if you have in your mind, you can directly type also, you will get here also the things. So you can directly fetch this. I'm connecting. I'm just connecting a linear frequency to angular frequency, and I'll show you that what is the role of this model initialization step. This is constant one. You can I for the better compatibility, I name it as F. Okay. Here also I name it as F. Okay. For here it is gain. Now I want to for changing linear frequency to angular, it is 2 pi f. So I just write the formula. So what you will write, 2 into bracket open np dot pi. Okay. So this you will write. Okay. Then you can click on the OK button. This is NP we are using for numpy. So don't get confused. In Python, we use NP for numpy. That is numerical Python. Okay. Here I can use using angular frequency to naming it as this is how. Now in model initialization step, I need to assign the value for frequency, otherwise it will show error. So you can assign here that f equals to 50. Okay. Okay. Now you can directly, I'll show this when I have on the button this compile, I need to say just I write it. Okay. So see here it is the message console. It is showing that all the things are, it will evaluate. Even if you are connected to a complex model, it is showing all the part of the library. See how many codes we have used. Okay, that is also, see, I have not used any complex model, a simple model, simple just converting linear frequency, but still it is showing that I have not used any codes. It is showing 0, standard processing core I have used 1, SPC 1 is used here, and TBF solver utilization delay, non-ideal switches I have not used any of them. So it is also it is given that in this configuration you can use 3, 4, 6, all these properties are given. Remember here it is also giving simulation time is step to 5 e to the power minus 0.7 second means 500 nanoseconds it is given. And scale discretization step it is also given. So everything it has mentioned. In fact, it has also mentioned the electrical part of the compiler. That is, this is the signal processing to variable utilization. I was telling you that how much you can use for this 404 or 402. Then signal processing probes utilization. Then digital probe utilization. Then all, see, everything is no error. So it is showing that compilation is finished properly. When I clicked on this compile, if you want to see, if you want to get the detailed study of this message console, if anything comes in the orange part, orange color, it shows a warning because we are using just a means our according to our desire we want to fetch the value, then it will show a warning, but it doesn't mean that it is an error. If it will be an error, it will show in red color. Okay. So I just here. Then now from here, I'll just compile and open reload model in HIL SCADA. I'll just load model in HIL SCADA. I'll just be finishing within while as I finish this, just to show you, to give you an idea. Otherwise, you all will be doing hands-on, then it will be easy for you. And even if you have today, you have installed the software, you can go ahead with the installation of the software. You can open any of the example model and you can run and you can get the simulation, but don't make any changes in the example model. So here I will create new panel. I'll just fetch a simple digital display here so that you can see the results. Okay, so here the digital display output I was getting in Pro. So I'm getting fetching Pro from here. It will show in here. From here you can copy the same. Control V. Okay. You can save the panel also. Okay. If you want to load any panel already, if you have saved somewhere, you can load the panel. You can save the model also. Model settings, it is given save model. Panel also you can save. You can, if you want to view best zoom in or zoom out, all these features you can do from here. See how I have used the digital display action from here. Now I can start my simulation from here. See, this is the result I'm getting. You can do many more things while doing here. You can enter the script also. And when you will be doing the models, you will be seeing that if you're using any of the widgets for like for a slider, if you want to range something, you can use. See, I have not used anything like that I need to something change. But if you are giving any input voltage or something, you can use the slider button. Then you can use the gaze also. Gaze widget also you can use from here. This is gaze for output. If you want to see what is the input you are getting, then what is the output according to the input, how the output changes, you can select from here. Since I have not made the model of that time, so I cannot use this widget here. But you can use if you are using some models, or otherwise you can open the example model and you can go through and you can see the how the this panel widgets are made. Okay, in fact, you can go for the graph also. You can have this, you can plot the graph option also. Okay, so this also you can do if you are using, you can use all these graph techniques for trace graph if you want to, like for IGBTs, if you want to trace graph for each leg, what you're getting. So you can use this widget and you can use that, you can add the signals and you can do it. Okay, so this can be done here. Similarly, for signal data logger, if you are using signal data logger, so if you are using the signal data logger, you can use, you can means you can check, you can use the panel directory where you want to save, you can fetch, you can browse from here. If you then add the signals, then for which you want, then it will be, you will be getting all these data in the form of Excel sheet of the current waveform or anything. Okay, so this is you can use here widgets in HIL SCADA. Okay. Similarly, you can, this is capture and scope we use for each and every. So here you can check capture and scope. Here you will get the waveform like here. You will get the scope. Again, you have to add the signals for the waveform you want to see. Then here you can vary the time steps. Then you can do, and you can, if you're switching towards the capture, then you have to import the settings from scope first. So first let it in scope form, then you can have the capture form. Okay. So this is how you can use the widgets from the library. Okay. So coming towards, so these are the virtual laboratories we are going to start very soon. So you can have the experience. Last but not the least, I would like to conclude that this our Typhoon HIL is means Typhoon HIL tools offers a very unique user experience free of third-party software and hardware complexities, and as a result, Typhoon HIL Control Center with all the libraries installs with a single click, models and compile in sequence in a very shortage of time. I have shown that how the digital inputs and how you can fetch from the library. These can be sampled with a second resolution and real time step as low as 500 nanoseconds on all Typhoon HIL products. So we deeply believe that less is more. So when it comes to the test equipment that our users love, so we stand behind our seamlessly integrated technology stack from Typhoon HILs. Application specific processor and ultra robust numerical processor all the way to the schematic editor in the SCADA system. So this complete technology stack that empowers our users to continuously exceed their controllers of their quality, performance, and time-to-time market goals because we are already upgrading ourselves and our technology according to the user needs. So here I conclude. If anyone have queries, you can have the question. Otherwise, already I think if you must be answer. Um, Already if you have posted the questions on chat box, you must have been have got answered of the questions. If any other queries left, you can ask. I and my team is present here.
Yes, thank you, ma'am. Thank you for the session. It was a lovely presentation from your side, and rest all the information will be shared to you via a WhatsApp group as well as mail. And regarding license, I like to add some points that it will get updated by evening. Else, if you want, you can download it by the steps provided, steps shown by the mom itself. So you can go to typhoon.com, from there go to products, choose the device, and from there you can download the software. So if you have any queries, you can ask over here. Rest we can answer it on the WhatsApp group also.
I have one question.
That's
Ma'am, I found that in the Typhoon HIL, there is a single switches are not available. We have to give always a request, then only they are going to respond. So when we are going to model some converter or inverter and any controllers designing, it's getting very problem if you are not providing the individual switches.
Sir, I would like to say that single switch is also available, but it comes when you purchase the device. And second of that thing is that all the converters which you require is already available in Typhoon model. And if you click on single phase inverter, over there will be a control option as model. And also tomorrow I will demonstrate that part, that how we can control individual switches of the single phase inverter or three phase inverter, and how you can design the circuit. So I think it will please wait for the tomorrow session, so you will get some idea about the controlling of the individual system without that.
We have already purchased in our university, Typhoon HIL. So that's why we
Okay.
are already at the time of demo, they told that we have to send a request, then we will send you the link regarding the updated version of switches, but still we are not received. That's why I'm asking.
Sir, can you please share your query on in support platform, which has support platform?
Uh, from which college you are talking, sir?
VIT.
Hello. Hello. VIT, Vellore.
Yes, yes.
Hello.
Sir, you can also create a ticket from here.
Actually, I think I have. This is the training part, so you need to connect personally. And the second thing, if you are asked us to open the switch part, so I think I have requested to send the detail what you want to design. Okay, and we verify that what design is what and is not available in the idea. So, I think this is not the right place to discuss.
If anyone is having means a query like this, as the sir has said, you can also leave us a mail, or you can create a open ticket system by going to the this support icon, and here you can click regarding with the topic, and whatever you want, you can just give us. We will update and we will give the updated versions along with that according to the requirement. Okay, then you have to create a ticket here. And sir, we will update you very soon with the things. Just mail us.
Query left from everyone. Okay, ma'am, thank you. I think there is no such query left from the participant sides. I think we should end up the session over here, and we'll meet tomorrow on the same time from 10 o'clock. And recordings will be provided to you on WhatsApp group as well. So thank you everyone. Thank you for attending the session. Have a nice day.
Okay, thank you, sir, and thank you, the team of Anurag University.